All right. Well, hello, everybody. So it's time for a brand new podcast episode of the, what do we call ourselves? We're the Generative AI Meetup Podcast. But basically, we just go and chat about AI and just random things. So with your hosts, myself, Mark, and Shashank. So together we run a meetup in the Bay Area. Some may call it Silicon Valley. We've been running the meetup for about a year and a half now, and it's a weekly meetup, and we meet a lot of really cool people, and we talk about a lot of interesting topics, and some of the people that we talk to and some of the interesting topics that we learn about, we try to share that with you here on the podcast. So we wanted to bring our meetup from Silicon Valley to the world. So wherever you are in the world, thank you for listening. So there's a lot of news this week. We didn't have an episode last week, so a lot of things to talk about this week. So probably the first thing we want to talk about this week is Cerebras. So I think it was a few months ago we interviewed Matt from Cerebras. Matt, I don't want to mispronounce his last name, Matt Su from Cerebras. And it was a fantastic interview. So like a 2-hour long interview. He goes like deep for like the first hour and talks all about their chips. But they just came out with a brand new inference solution. So inference, like using the models, basically it's like, how fast does the model respond? It's basically instant. I think it's like one of the fastest inference solutions that has ever been made. It's incredibly impressive. I've played around with it a little bit. Amazing. Yeah, Shashank, I don't know, have you tried it yet?
I have not tried it yet. I was a little sad because Matt did invite us to try out the beta before it was released, but just a lot going on. But I did check out their blog post and looking at the speed. So for context, Cerebras is yet another chip company, but what makes them different is that they focus on wafer scale computing. I actually have a giant wafer sitting here next to me that I wanted to show Mark. So most of the chips are made from like a large wafer that's about maybe like 10, 12 inches or so. And
But yeah, when we're talking about wafer, sorry to cut you off, Shashank. Like the wafer is like I didn't realize how big. Yeah, it's about the size of a frisbee, like a dinner plate.
It's flat.
Yeah,
it's perfectly flat with a lot of chips etched onto it with a really, really expensive laser that this Dutch company or Danish company makes. And the GPUs are cut out of this large circular wafer, and you get maybe tens of chips depending on the size of the chip. But what Cerebras does is it uses the entire wafer as a single chip and maybe like cuts off the ends of it to make it like a large square that is contained inside this big circular disc. And so they have the biggest chip on the planet. It is maybe, I forget the exact numbers, but like 5 to 10 times the size of like an NVIDIA chip. Don't quote me on this, but it is much bigger than the NVIDIA chip. And initially, they were using this for training. Their biggest customers were some of the Middle Eastern coalitions, groups of countries that have banded together and
like
raised a lot. That's right.
Yeah.
So the G42 has raised a lot of money, and they have large supercomputer clusters, and which are made up of a bunch of Cerebras nodes, and they've historically been using it for training. And the last I spoke to Matt from Cerebras, who comes to our meetup pretty regularly, he was talking about how they partnered with Qualcomm to help with inference. So once the whoever, G20, let's say, has trained a large model for their specific use case, then they deploy it onto these edge devices, your mobile phones or IoT devices, whatever it may be, that are running Qualcomm Snapdragon chips, which most Android phones run. And that is optimized for inference. But, behind the scenes, secretly, they've been working on an inference solution with the same large, massive chip. It is so freaking fast. The previous fastest solution was Grok with the Q, which was also started by previous former Googlers who worked on the TPU at Google, and then they decided they wanted to spin off and do their own thing for a bit, and they came up with an LPU, a language processing unit, which got a lot of press, and it was really, really fast. That blew my mind. That was like 10 times faster than NVIDIA GPUs. And this thing, I think, is like twice as fast as Grok. So it's like blazing fast. It's instant. You don't need to wait at all for the biggest models.
Yeah, it's wild. Like I tried it out and I typed in my question, and like you just see, like I type it in, as soon as I hit enter, you just see a block of text response. I mean, like when you wait for ChatGPT, it's like, I mean, it takes like a few seconds to get the response. I think like when I use Claude, it takes a few seconds. Like, oh, I'm thinking about it. With this, it's just like, no, you get the response immediately. And it really just makes me excited for like all of the use cases that you could use this for. Like just having fast inference is so nice. And not only is it fast, but it's also cheap too. So I think for reference, I want to say Claude, if you pay for that, it's like, I want to say it's like $15 or $20 for every million tokens that you use.
How much?
I think it's like $15 or $20.
Whoa.
For a million tokens. Yeah.
That's crazy.
Yeah. Whereas this is, I think it's 10 cents.
It says 60 cents per million token.
This is 60 cents?
Yeah.
Oh, okay.
Per million token.
Yeah. I mean, so 60 cents was like $20. I mean, like, that's wild.
That is wild.
Yeah. So I think that like you're going to see a lot of use cases in this for like agentic workflows. So like, for like agents.
So for context, OpenAI's pricing for GPT-4o is $5 or $15. They have two pricing models. I'm not sure what the difference is.
It's like input versus output.
It may be input versus output. Yeah. So it's 5 or 15 depending on input and output.
Okay. So
inference is output. Yeah. So $15.
Oh wow.
For a million token output for GPT-4o, and this is 60 cents. But to be fair, they are talking about Llama 370B.
Well, we don't know like exactly how to compare the two, like the Llama 370B and GPT-4o, but they're not that far apart, I think.
Let's see. Maybe we can compare it to GPT 3.5 Turbo. Llama.
No, I think it's better than GPT 3.5 Turbo because is this Llama 3 or 3.1?
3.1 70B.
Yeah, I think 3.1.
Just for the sake of comparison, GPT 3.5 Turbo is $6 for a million tokens output.
Wow.
So this is still 10 times cheaper than a worse model from OpenAI.
Yeah, I mean, that's just silly. I mean,
order of magnitude. Magnitude. Amazing.
I mean, whatever moat OpenAI had, it's lost.
Well, no reason OpenAI can't use Cerebras for their inference.
Good point.
This is more a competitor to NVIDIA, I would say.
So maybe I should like start buying some Cerebras stock.
Yeah, let's drive up the secondary market shares for Cerebras and help out our friends at Cerebras.
Not invested in Vice.
Not at all.
I actually don't own any Cerebras.
Neither do I.
Thinking about it now. Thinking about buying it. But don't take our advice. We're not like financial advisors or anything like that. We don't know what we're talking about for this. Yeah, just don't buy it. I mean, like, buy it if you want, but don't buy it because we told you to.
Do your due diligence.
Yes.
But thinking about how they achieved both this high throughput and low cost, it has to be the wafer scale. Because if you think about NVIDIA chips, the GPUs, they have smaller capacity, so you have to like split up the task into separate batches or something, and then have each different GPU do some computation, and then tabulate the results. So we have a lot of bottlenecks, a lot of networking, a lot of memory caches to store the intermediate results. I would assume that this just does away with all of that.
Yes, I think so. And also, I remember Matt during the podcast, he was mentioning that NVIDIA needs to be kind of general purpose, where apparently in LLMs, you get a lot of zeros. So, like, if you multiply any number by 0, you're going to get 0, right?
Yep.
And there is apparently that optimization done on done on the Cerebras chips where, if they see a 0, they just know they can skip some things and the output's can be 0. And that will save them a lot of compute as well. Whereas like NVIDIA's GPUs, it's got to work for everything, right? It's got to work for video games, it's got to work for AI training, it's got to work for AI inference. Like, I mean, this is like a purpose-built chip. I assume it's purpose-built specifically only for inference, which I think that you're going to get a lot of performance gains, because you're on one big chip, and also because you built it only for inference. It's like you can't probably play like Minecraft on this.
Yeah, I guess they have separate chips, one for training and one for inference then?
I assume so.
Yeah.
I mean, I don't know if that's public knowledge, but I would assume that that's probably the case.
Yeah, I do remember NVIDIA had some kind of a trade-off. They had some cores focused on training, some focused on inference, and they did some intermediate approach that allowed for both.
Yeah. And also I think that having this really fast and cheap inference is going to make it open to real-time use cases. Yeah. So we don't really see it where there's real-time translation. If you use Google Translate, it's a little bit slower than real-time. But I would imagine that right now, if I could, speak and then do my text to speech or the speech to text, right? And then I could feed that to the LLM and I want to output into a new model, I could probably do use this for realistically real-time translation. And I think it could help anything like real-time. For example, if I'm using a customer support agent that I'm talking to on the phone, I don't want to say hello, representative, right? And it just says you have to wait 5 seconds. It's oh, thank you for calling. It can just respond naturally, and I think that is going to be a really exciting use case where people are going to be able to use something like Cerebras for real-time LLM use cases, which we don't have right now.
Yeah, let's think about some real-time use cases. So customer service, live support, any live experiences make sense where you want to get feedback immediately. So some of the Google I/O announcements had this version of Gemini where you just take your Pixel phone and you have the video camera open in the Gemini app, and you're just showing it things and it recognizes exactly what you're looking at. You talk to it, you're asking questions, and it's giving you feedback immediately. Or even OpenAI's the voice GPT-4o with human natural voice demo where you're talking to it in natural language and it responds and you're able to interrupt it in real time and it takes that feedback and responds quickly. That would be so much more fluid and less robotic than what we have today, where you have to keep talking. The second you stop, it takes that as an input and then starts responding, and you can't pause it and you have to wait for it to finish. Or you have to hold that mic button and keep talking until you finish and then release and then wait for a response. It could be a streaming bi-directional input-output, which would be really cool.
Yeah. I mean, the thing is, it doesn't need to be that fast, right? I mean, it just needs to be about as fast as you can talk, or maybe in the future, it'll be as fast as you can think.
Oh, yeah.
Yeah, right? It's once you connect this to your brain, right, then you could output your thoughts to the LLM as quickly as possible, just stream of conscious. I feel it's faster than that.
It's faster than you can think? Yeah, maybe.
I think so, yeah.
Well, I mean, it's definitely faster than we can form words.
Yeah, but the thing is I tend to form words at the exact same speed that I think. Maybe you can think faster than you speak.
I can definitely think faster than I speak,
but I can't. I'm processing all of this in real time.
Interesting.
Yeah.
Well, it would also allow for other modalities. So text is really fast, but like vision would, I assume, be much slower. And then if you add vision and audio, maybe like other signals.
Yeah, I think so. But the thing is the technology is there to do real time audio processing and real time speech output. Like,
Sure.
that is there, right? So I think that like it's not like a huge technological leap to say like, hey, like I have this text, I'll put it in real time. Because it's like you're gonna have the text basically immediately. Like, let's say it's like a few hundred milliseconds. I think it's, what is it, like under 200 milliseconds is like imperceivable.
Yeah.
There's like some sort of metric for that. Under like a few hundred milliseconds, like the human wouldn't be able to tell. So let's say like you're able to get the LLM inference in like, let's say like 100 milliseconds. Then you have another 200 milliseconds to start outputting responses. And like the amount of words that you can speak per minute isn't that fast, right? So it's like if I could have an LLM inference and I can get I don't know, let's say, just to throw out some numbers, let's say like 1,000 tokens in 100 milliseconds. Well, I can only maybe speak like, I don't know, 100 words a minute, 60 words a minute, something like that. Well, now it's like if I'm speaking 100 words a minute, but I just generated 1,000 tokens in 100 milliseconds. Well, now like that's like far faster than real time. So then you could have like a real like lifelike conversation. So like even like something simple like, I don't know, you could probably replace all the drive-thrus at these fast food restaurants with LLMs. Like, why do I need to talk to somebody when like the LLM could probably just like understand what I'm saying?
I think it can.
Yeah.
So thinking about a couple other use cases, we were talking about agents for a couple episodes. That's definitely something that requires long outputs, multiple runs of the LLM, multiple runs of multiple LLMs, which rely on each other's inputs, outputs, and being able to run a complex agentic workflow and maybe have like 100 different steps execute and still respond in like a quick time frame. That would be really cool with Cerebras.
Yeah, really cool. And also, this is like the worst it'll ever be. It's just getting better, right? So, one thing that I've been playing around with is, so Ollama, I think it was a week or two ago, they came out with Ollama tools. So basically, it allows. I think we've talked about Ollama on the podcast a few times. Ollama is a tool, not to be confused with Llama, which is the open source LLMs from Facebook. This is Ollama, which is a tool that helps you run open source LLMs. They came out with a new thing which allows you to use tools. So basically, you can tell the LLM, say like, hey, LLM, like you don't normally know what time it is, right? But now you do. I'm going to tell you that you have access to a clock. So if anybody asks you what time it is, like you can use the time in the response. So then what I can do is I can say like, hey, Llama, or hey, like Llama 3.1, like what time is it? And it'll tell me the time. So I was playing around with that. I was trying to make like a little tool just to, explore the tool creation on Ollama. And I found that sometimes there was a little bit of stochastic randomness. So sometimes I would ask like, hey, what time is it? And it would tell me the time. I'd be like, what time is it? It's 12:01. What time is it? It's 12:01. And then I ask again, like, what time is it? And like, I have no idea. I'm not sure what time it is. I'm just a large language model. I have no idea what time it is. So it's like, I think that you would get less issues like that on these bigger and better models. Because this was a model that was ran locally on my MacBook Air. I don't remember which model I was using. I think I was using it was the Phi model, which is like the 1.5 billion parameter model from Microsoft. Because that one runs, fast on my MacBook Air. But if I could have used Cerebras, and if I told Cerebras, hey, I have access to a clock, tell me what time it is, and I was using the Llama 70B, it would probably get it the majority of the time, I would assume.
Yeah, speaking of smaller models, I was reading this announcement by AI 21. It's this, I don't know, it's like another Israeli AI NLP company. And I think they released like this, sorry, my bad. It's AI2, which is a different company. It's the Paul Allen Institute.
Wait, so there's an AI 1, you said?
AI 21.
Oh, 21.
And there's an AI 2. And I got those mixed up. But yeah, so AI 2, Paul Allen's from Microsoft, who's their late founder, they released a tiny model, like 1 billion parameter mixture of experts. So actually, they haven't mentioned how big the full model is, but at any given point, it's a very sparse model that only activates 1 billion parameters at a time. And there's like a cost versus performance graph. And this is the best performing at the lowest cost out of any other models. So usually there's like a 45-degree line where as models get better and better, they cost more and more. So all the Llama models are like way on the right. But this one is way on the left, very cheap, but very high performance. So I could imagine, especially with Cerebras doing really well at sparse models, we could run large mixture of experts models that have very, very low cost, really good performance, and take advantage of all the good stuff that Cerebras has, just as a side note.
Yeah, that's a good point. So I'm just trying to think, if it was a 1 billion parameter model,
yeah,
like how much like a RAM and like compute would I need to like run something like that? Because I think there's like a rule of thumb, isn't it? Like for every like billion parameter, it's like you double it. It's like, what is that? Like 2 gigabytes, something like that. Yeah,
that sounds right.
Because I mean, like my MacBook Air, I think is like 8. I think it has 8 gigabytes of RAM. Mm-hmm. So this would only take up like 2 gigabytes of RAM. So that's pretty good. I mean, that's like less than like a Chrome tab or something.
Yeah. Mine has 16 gigabytes of RAM, and I've been able to run the 8 billion parameter models easily. 11, 13, it can, but it struggles, and occasionally like my computer dies. So
yeah, I mean, so this you could probably run on like almost any
phone.
Yeah, phone.
Maybe your watch.
I guess. Yeah. Watch. Yeah, I don't know how much RAM is in like an iPhone or Apple Watch.
I would say a gigabyte or 2.
Yeah, sure. Probably like some even like low end tablets, like even maybe like a Raspberry Pi or something like that.
That's nuts.
Yeah.
So we've been talking about tiny models. So what about some of the big models, long context windows? Claude. So Claude released a thing for enterprise where they support 500,000 tokens of context window.
500,000. That's pretty big.
500,000. Yeah.
But that is smaller than Google's model, right? Because I thought Google, their Gemini Advanced was 1 million, right?
Yeah, that's right.
Yeah.
It's
still pretty big.
Ballpark. Yeah.
Not too far away.
No, not too far.
It's on the same, like, it's not an order of magnitude difference or anything like that. It's like linearly, like double. I mean, that's not like crazy. But 500 million. Or what'd you say?
500,000.
500,000.
500,000.
That's a lot smaller than 100 million.
Oh,
yeah.
We're getting big.
Yeah, really big.
What's 100 million?
Yeah, so this company called Magic.dev, they announced a model with 100 million token context window.
So what is Magic.dev?
They are a company that is from their website working on frontier scale code models. So they're trying to build some sort of coworker. I think they're really trying to help with like code generation. I don't know much about it. They're a little bit secretive on the exact details that they give, because I don't actually know if you can like use their model yet. That's my understanding, is like you can't actually use it. If somebody from Magic is listening and you can, well then I'm sorry. Reach out and let us use it. We'd love to try it. But I think the thing with like, if you're going to try to do programming, like oftentimes like a code base is like significantly larger than that you could fit in a context window, right? So like Android, the open source operating system, I don't know how big it is, but I would imagine I think that like if you try to install on your computer, it's like hundreds of gigabytes.
Yeah, 50 gigabyte by itself.
And I think it might even be, I think that's maybe like the base, but I think that like in practice, you probably want something like a couple hundred gigabytes, right? So it's like, if we're going to start trying to make like a change in Android, and that's 50 gigabytes, like at the minimum, I mean, you're going to need like a giant context window for that, right? If you want to fit that thing in. So I think that, I mean, Android is a little bit of an extreme case. I mean, I don't think most programs are significantly smaller than Android.
It says Android is made up of 12 to 15 million lines of code.
Yeah. So I don't know, we could do some math. If actually, how many tokens would be a gigabyte? Let's see, because like I guess one token, that would be like 1 byte, I assume. Right? So roughly, is that right? Is a token a byte? No, probably more than a byte. No, one byte would be like one character, right?
Let's think about lines of code versus tokens. The paper on or the blog post on magic.dev says it assumes a line is about 10 tokens.
Okay, sure. So you said Android was how many?
15 million. So we need like 1.5 million, or we need 150 million tokens.
Okay. So they have 100 million and we need 150 million.
Yeah.
We're almost there.
Almost there. Almost there. Wow.
We're almost there to work on the biggest chunk of code that I can think of.
Yeah.
I mean, I don't think it's pretty
Microsoft. OS,
yeah, maybe like Windows.
Apple.
Yeah. But those are all closed source, so we don't know exactly how big those are. But I don't think there's too many code bases that are bigger than that. I mean,
Facebook, maybe Google search.
Yeah, could be. But we don't know. It's too secret.
Yeah.
So, but yeah, I mean, we're getting to a point where almost anybody would be able to just like put in their entire code base into the LLM and be like, hey, build me this feature.
Yeah, so looking into their blog post, they seem to have taken some clever hashing principles to store the context of the code in some kind of a sensible grouping, because you don't want to store like the structure of the for loop in different parts of the code and return that as a result, because like maybe that doesn't really make sense. Maybe you want to store the context around the for loop that does something more meaningful, like as part of the project in the hash. So if you're searching for stuff, then it returns a bigger chunk that has more information.
So it's almost like they're like running like some sort of minification algorithm on it, kind of. So it's like,
it seems very similar to the RAG approach, except they have some they've coined it hash hop, where they hash different chunks which link to other chunks semantically, in the sense of whatever semantics the code has.
So I don't know if I like 100% understand it, but whatever it is, it's cool. So Magic, that's awesome.
Yeah,
like 100 million, that's a big number.
It's really cool.
Yeah, so we applaud you. And then you said there was one other company that is making a really big context window as well.
Well, not specifically a big context window, but NVIDIA has released a paper which promotes an approach with RAG to rival the performance of models with large context windows. So they tried to overcome some of the limitations of early LLMs using RAGs, where you got to get the chunk size right, because RAG, retrieval augmented generation, looks through a vector of chunks that you've made out of a given document, but that's only useful if each chunk is of a certain size, large enough to hold meaningful information. Otherwise, if you break up a meaningful paragraph into too many chunks, then the meaning is kind of lost across too many different chunks. So when you retrieve specific chunks to answer a question, it may not contain like that full information.
Yeah. So for example, just to go off on this a little bit, if you were working in RAG, let's say I took the book Harry Potter, right? And now Harry Potter, well, with 100 million contacts, you could just put the whole thing in. You could ask questions about it, right? But for a lot of these models, they have a smaller context window than the entire length of like a book, right? So let's say I took Harry Potter and I decided I'm going to chunk it by page. So I'm going to say like, hey, LLM, like find the relevant page. So maybe it might be able to tell me like factual information where like all the information is on one page of Harry Potter. It's like, oh, like Harry Potter, where does he go to school? It's like, oh, he goes to school at Hogwarts. Because that would be like, one fact that you could probably have with one inside like a single page, right? But if there was something that was more like widespread, like some sort of like story arc that had that couldn't be fit into like one page, which I can't really think of an example right now, but if there was something like that, I don't know, like if you ask like how did Harry progress over the first the book between like the beginning and the end, you wouldn't be able to really answer that question through RAG. But if you were able to put the entire book into a context window, you might be able to actually answer that question, like, kind of like character development over time.
Yeah, so this paper from NVIDIA, it fixes the limitations of traditional RAG with something that they called order-preserved RAG, where they store the chunks related to each other, which supposedly helps preserve the context of these separate chunks. So yeah, cool research being done to extend the context through a lot of other hacks and interesting strategies.
That's incredibly exciting. And there was one other thing that you were mentioning that was really exciting around gaming.
Oh, yeah. So this was a really cool model. I thought it was mind-blowing. So we have the whole game of Doom generated by a diffusion model that was trained on who knows, several hundred thousands of hours of gameplay of actual Doom. And it renders each frame dynamically through the diffusion models based on like the controller input and the existing current frame.
Okay, so to make sure I understand this correctly, like a diffusion model is a thing that we typically use to generate like images, right? Like stable diffusion. Like I put in an image prompt. It's like I want a horse jumping over like a fence, and it would generate that image, right?
Yeah.
But this is not generating an image, and it's not even generating a video either, because like
it is generating an image at one frame at a time.
Yeah. So I mean, like I guess it's generating images at like maybe 60 images per second.
Yeah.
And also like 60 images per second that is generated. And also I would assume it's taking in some metadata, maybe like
controller input,
which direction is like my mouse moving.
Yep.
Like, am I looking up, down, left, right? And it's generating like images based off of that. So
and randomly creates enemies that spawn and like send attacks. It creates like messages when you approach a door that says, oh, this door requires a red key or whatever. And like animates the movement of your hand with the gun in front of you as you're walking. It bobs up and down. You can switch weapons. You can like punch. It'll do the punching action. So it's really cool. This demo is 1.5 minutes long. So I don't know how many frames per second. Oh, this actually says 20 frames per second. So
okay.
Like that 1,200, 1,500 frames, let's say. And it's cohesive. This whole 1.5 minute gameplay is sensible. It doesn't have too many artifacts, and they handed this over to a couple gaming enthusiasts, and they couldn't identify it. They couldn't identify which one was auto-generated and which one was real. significantly better than like a random score.
Wow.
It's really close.
So what we're saying now is, as opposed to LLMs generating images, they're just going to be generating like complete video games that I can play. I mean, that's pretty cool.
That's pretty cool.
But not to. I think so. Let me preface. I think this is a wonderful accomplishment and super cool.
Yeah.
The only thing is though, I wish it was a game that didn't already exist.
Sure.
Right? Because like right now, like we don't know, like I mean, the thing is, if I train it on Doom and then it generates like Doom, it's like you're just like generating like what's already in your training set. So it's like I mean, like it's cool, but it's like it's less impressive to me than like if they generated some sort of game that never existed, right? Like if they made like Doom, but like I don't know, like it was not like it didn't look like Doom, but it was played with like dinosaurs or something like that. Like I'd be more impressed because it'd be like, hey, look, that's something that we haven't seen before. Like, or if you could train on like multiple video games, and then it could be like, hey, it looks like you like to play role-playing games that are first-person shooter that are located in space, but everybody's pirates. Like, I want to see an LLM create something like that, and then I could play like a game that nobody's ever played before. Now that'd be, I think that's where it's going. But you know, just the fact that like it regurgitated a game that's already in its training set, like I mean, it's cool, but like I don't know, I want to see it like generate something new.
I mean, I agree, but I think this is a proof of concept that is paving the way for that future that you're thinking of. So I can think of a lot of potential possibilities with this. So you build a single game, let's say Doom 3D, and then it works for one single platform, one version of one single platform. With this, you feed it in a specific game, and boom, you're able to generate images and a video that can be ported over to any platform. I assume, as with previous image models and, diffusion models, and even before that, we had like style transfer learning. I assume you can like switch the textures and visuals to create like a different theme. It could be like space aliens, like you were talking about, or a Western cowboy theme. And then, take that line of thinking a little one step further and change the character and change the gameplay a little bit. Instead of a first-person shooter, it's like a racing car game or a third-person game and a side-scroller. I'm sure a couple papers down the line, we'll get to that future.
Yeah, I think so. That's an exciting future. I mean, it could be that in the future we don't even have like game developers, or maybe like the game developers are working with the LLMs, like try to prompt it. Because I don't know, I'm not sure if maybe it will, like given enough time, but I think it'll be a while before LLMs are like making games that are actually like really good. I mean, like Doom is a good game, but I mean, when did it come out? It came out like 40 years ago.
It came out like,
right? I think it was like the 80s or something like that.
But I mean, we're still playing like Flappy Bird or whatever the latest one-hit wonder game is. It's low fidelity. It doesn't have to be that complex. It's running on your mobile phone with pixelated graphics, and people still find value in that.
I mean, sure, right? But like, I want Red Dead Redemption.
AAA, high production value.
Exactly.
That takes like years to develop and has a budget bigger than some blockbuster movies.
Yeah, I want that. I think the people who are working at those game studios, their jobs are still safe.
Yeah, they're probably using a different set of tools to create textures more easily, create game dialogue maybe, create like 3D models, and use all of these AI tools to aid that process.
Yeah, I mean, I think that makes sense. And I think it'll be cool, like, if you could have like maybe like AI models in game where you could have like a little bit more randomness. But I think there still is something to be said about having everybody play the same game.
Yeah.
Right? Because like, even if like we could generate like a brand new game where everybody got something different, I think there is something to be said about like a shared experience where like, hey, like we all saw the same movie, we all played the same game, we could talk about it. If everybody gets their own same game, we're just like gonna be further divided into like our own little bubbles where we just surround ourselves with things that we like. And I mean, we're kind of getting there a little bit now with like social media and whatnot, where everybody sees their own content feed. Like if my Twitter or X is different, it's gonna be different than your Twitter or X because it's I followed a different set of people. I probably look longer at like certain images than like you would at certain things, and we're just gonna see something different. And like, I don't know. I guess it's like a commentary on the world that like we're gonna like if that's where this is going, we're gonna see our own video game. Like we're gonna maybe lose some of that shared experience.
I'm with you there. I think it's a very evocative thought to think about a future where we're separated from like this collective consciousness, this pop culture that we all get to partake in. And instead, we're living in our own little silo, like the loneliness epidemic that's having everyone in their own little box in this concrete jungle. It's even more siloed. And that's kind of a sad thought. But, if it brings us joy and happiness, maybe that is the dystopian future that we're headed to. But I see your point. I think this was an argument that a lot of people made when the vision models came out, like Sora. We were like, oh, what if we're all sitting, turning on our own personal Netflix channel and watching these amazing movies, TV shows, or whatever. But, it's cool and we can't share this with anyone. Like, who do we talk to about? And like, no one else knows what we're going through or what we're watching. And it's a little more disconnected from reality.
Yeah, very true. But do you know what everybody could all gather around the water cooler and talk about? Is this podcast right here. So we're trying to make that shared experience. And all of you guys who are listening, feel free, tell your friends, rate us on all your podcast players, Apple Podcasts. You can leave up to 5 stars. So, please do. It'll help. We're trying to, juice those numbers. So whatever you can do, share with your friends, please do so. And if you happen to be in the Bay Area, which I know a lot of you listening are, please come to the meetup. We'd love to talk to you. But anyways, yeah. So, and speaking of the meetup, it's starting soon, so we gotta run. But yeah, thank you so much for listening to the podcast.
Thanks, everyone. Until next time.